Okay, we're starting with Chapter 6. Chapter 6, we're going to start learning about trigonomic functions. We're going to start graphing some trig functions. I'm going to start off with Desmos. I'm going to start off with Desmos here. So you start getting a little bit of an idea of what graphs look like. We've already done sine graphs, okay? So you got to look at a sine graph, say of x. And it looks like what? Like a sound wave, right? Sound wave. And we're going to learn, as we get into other chapters, we're going to learn about amplitude and phase shifts and that kind of thing with the sine waves, which really starts getting into physics. A lot of physics type stuff. All right. So we got a sine graph here. What if we were going to take this and do another one with the cosine, or not the cosine, the cosecant? What would that look like? Do you think it would go a different direction? It's the same thing? It'd be down farther, up higher? What it's looking like, it isn't a wave. It's not like a sine wave. What it's doing is, if you notice, at a certain point, and at this point where sine is 0, it will never touch. All right? Where sine is 0 here, it never touches it. It's like a parabola that is restricted by where the sine wave equals 0. Right? Yes. That's the way they say it. Cosecant. Okay? So, if we know that, let's get rid of these two. Let's take a look at the, there it is. Come on, show keyboard. Let's take a look at my cosine of x, which is nothing more than the sine of x shifted a little bit. What do you think I don't want to put that there. What do you think the secant will look like? So the sine, same thing as the sine, and the cosecant. Okay, if you take a look where cosine equals 0, it's never going to quite touch that point. All right, it's going to get real close to it, but never quite touch it. What does that usually mean? It usually means that it's undefined at that point. All right, so if you look at this, if it never can touch where the cotangent or where the cosine can hit, then the secant is actually undefined at that point. It's where the cosine is 0 over some number. And remember, the secant is the reverse of it. We're flipping it over. So that's going to be like something over 0. And that's why it can never be defined at that point. Yep. Pi negative 1. Okay? All right. Tangent. Remember what tangent looks like? Okay, remember tangent. Tangent hits a point, okay, where it cannot equal a certain point. So if we were to look somewhere like right in here, I don't know if it would even tell us what that point would be. Nope. All right. I wish I'd get this working with radians instead of degrees. But the tangent comes up and doesn't equal at what? I wanted it to be in radians. Right up here. I think I've looked at this stuff before. My little gear doesn't do anything for me. Nope. All right. So you got your tools up here. But I want it to show up here as saying the radians here. What's pi? What's 2 pi? All right. So what can't tangent equal? Where is it undefined? Tangent of 0 is 0. Where's it at? It would maybe help then if we did this. Let's put in the sign, because we know where the sign crosses, right? Oop, I didn't want to do that. Well, the sign crosses here is what? Pi over, it's pi, right? And this would be 2 pi, so this is pi over 2 and 3 pi over 2. So at 90 degrees, tangent of 90 degrees is what? It's what? Undefined. It's undefined. Tangent of 270 is undefined. All right? So you can look at this and say, okay, my tangent now, you know what my tangent looks like? It's between 90 and 270, that 180 degrees in here, right, from over here to over in here, wherever that is. All right, that's a 180 degree shift, and you know it's going to have this type of shape. What's my cotangent going to look like? Remember, we're flipping it, right? We're flipping it upside down. It's going to go the opposite direction, but it's going to be shifted what? 90 degrees over. It's shifted 90 degrees. What's that? Okay. It's shifted 90 degrees over, and it's also going the opposite direction. That's our cotangent. So that's the first things we have to understand, and Desmos is going to help you understand that as you work through this. Now, the next one I want to go through. I can probably clear this right out. I'm going to use an example of sine of 810 degrees. And we have to figure out what the sine of 810 degrees is. Now that's remembering that our sine looks like this, all right? Here's pi, here's 2 pi over here. We've got pi over 2, and we got 3 pi over 2. And we know that in a circle, which we're going to work off of, this goes around 360 degrees, right? How many 360s can we take out of that? 2. Left with 720, right? 720 degrees. Subtract that from 810. And we're left with 90 degrees. What's the sine of 90 degrees? 1. This is -1. The sine of 810 degrees is like the sine of 90 degrees, which is just, sine of 90 degrees is 1. So this here equals 1. We don't have to use a calculator for this. All right, we can determine that just by subtracting out our 360 degrees. knowing what our sign looks like. Okay? We can also work, remember this, all smart trig class. And we have our 30-60 and our 45-45. Our 30-60, which is 1, 2, square root of 3. Here's 60, here's 30. And then our 45-45, which is 1, 1, square root of 2. We can figure out what our degrees are based off of this type of information right here. Any questions? Anybody falling asleep? 1, 2, 3, 4. Good. Okay. What I want you to do, page 305. Yeah. Let's see. I want you to do 20 through 27. 20 through 27. And I want you to do 40 through 45.